Another method of understanding a polymer's behavior is the spring and dashpot model. The spring represents the elastic behavior of the polymer. The elastic portion of the model acts as a metal and has fully recoverable strain. The dashpot represents the viscous behavior of the polymer. The viscous portion of the model acts as a fluid and has unrecoverable strain. One way to understand the spring and dashpot model is by examining the behavior of the system with a suspended load. A graph of deformation and time helps you understand the mechanics of the system. The first component of the model is a spring. When a weight is added to the spring, an immediate deformation is observed. When the weight is removed, all of the elastic deformation is recovered. The second portion of the model involves a spring and dashpot in parallel. The spring portion of the system cannot immediately deform because the viscous component slows it down. Therefore, the deformation takes place over a period of time. As the weight is removed from the system, the deformation recovery of the spring is slowed by the dashpot. The third component of the model is the dashpot. The dashpot flows while the weight is applied to the system. When the weight is removed from the system, none of the viscous component is recovered. To fully understand the model, the three components must be superimposed. When the weight is applied, the system undergoes an immediate deformation due to the spring component. The second component, with the spring and dashpot in parallel, produces a deformation over time. The viscous deformation of the third component is added to the second component. This results in a model of the behavior of the loaded system over time. When the load is removed, the initial deformation of the spring is recovered. Then the deformation of the spring and dashpot is recovered over time. The deformation of the dashpot is never recovered. The result is a permanent deformation of the system.